Welcome to the next Bullseye presentation involving data analysis. My name's Mr. Harris, and I'll be leading you through several examples that involve data and how to solve problems in data analysis. PSSA Prep Data Analysis. In this presentation, we will look at several examples that involve the collecting of data and then presenting that data in charts and graphs to interpret that data and come up with results that make decisions. As you collect the data, we'll be looking at charts, graphs, and how we read those charts and graphs. What you'll need to know is to formulate answers and questions that can be addressed with data or organize, display, interpret, or analyze data. The key word here is data. Once that data is collected, you will want to interpret that data. One example of collecting data is to take the junior class and to look at the height of a sample of that junior class. We were looking at several examples that involve the height of the junior class, but in this next example, example number 1, let's look at a chart that's presented, and you're given the above relationship is a linear relationship. That's important for us to note, as we are asked to predict the number of highway deaths in the year 2005. Notice the chart only goes from 1990 to 1993, and we would like to know what is the predicted number of highway deaths in the year 2005. Let's take a closer look at the key concepts that involve this problem. Linear means the graph of the relationship is a line. The change in x values is proportional to the change in y values. What that means, as we look at this chart, from the year 1990 to 1991, 1 year of time, you have 7 less deaths. But this ratio that is consistent here of 1 year to 7 deaths is the same as we move through the years. In 1991 to 1992, again, there are 7 deaths. And the last year that we look here, 1992 to 1993, there is also, again, 7 less deaths. This means that this is a linear relationship, and if we were to continue this relationship, we're asked what will be the value of the deaths in 2005. For every 1 year change, there is a change in deaths of 7 years. The problem states that we are to predict the number of highway deaths in 2005. How many years after 1993 is it to 2005? Well, if you would just simply subtract, you would find that it is 12 years. Now, for every 1 year, there are 7 deaths. So, for every 1 year of 12 years, there is a change of 7 less deaths for each of those years. How many less deaths are there in the 12 years? Just simply take 12 times 7. 12 times 7 is 84 less deaths from 1993, and we want to go to 2005. That is a total change from the 1993 number of deaths, 184 minus 84, 100. And so therefore, our answer to the question of how many deaths will be in 2005 is 100. Let's move on. Looking at what we need in data analysis, you would like to be able to read presentations in what's called a box whisker. That key is the box whisker, which is made up of several key points. As you look at this example of the box whisker, the 5 values that you will need to be able to construct this is the minimum value, which is located on the far left, the maximum value, which is located at the right, and then the median is located right in the middle, also called quartile 2. And then there is what's called quartile 1 and quartile 3. It's important to note that the percentage of data from the min to quartile 1 is 25%, and quartile 1 to quartile 2, 25%, quartile 2 to quartile 3, 25%, and then, of course, quartile 3 to the maximum is 25%, giving you a total of 100%. In this particular problem, you're being asked to find out what range of values contains 50% of the data? Well, if we start with letter A, 10 to 20, you will see that from 10 out to 20 includes 3 quartiles, which would be 75%. A is not the correct answer. From 13 to 25, you have again 75% of the data represented. And then in letter C, you'll note it goes from 17 to 25. That would be from quartile 2 to quartile 3 to the maximum value, which would be 50% of the data. So our answer is letter C, 17 to 25. Now again, let's take this sample that we've collected from the junior class and find the mean, median, and mode. Let's reorganize the data. The first thing that you'll want to do here is arrange the data in order from lowest to highest. Now that might take a little time, but let's put that in order right now. You have then the lowest value is 59 all the way up to 74. In order to find first the mean, by definition, the mean is the sum of the data entries divided by the number of entries. We have 30. We would need first to add all the data values and then divide by 30. The total data values of all the numbers above is 1,987. We're going to divide that by 30, giving us 66.2. That would be the mean. Next, let's look at the median. By definition, the median is the data value that lies in the middle of all the data. Since our data is already arranged in order, which is important first to do, we can locate the center of this data, and that would be between 64 and 66. We have an even number of data values, so there will not be a specific data value right in the middle. So we need to take the average of the two numbers, 64 and 66. To find the average, add the two numbers and divide by 2, giving you 65. 65 is the median. Next, the mode, by definition, the data value with the greatest frequency, the one that basically occurs the most. As you look at the data up above, you will find that 64 appears 6 times, and it is the data value that appears the most. So therefore, our mode would be 64. Now, what we'd like to do next with the same data is to take the 5-point summary and construct the box whisker, which we've talked about before. It is made up of these 5 values: the minimum, quartile 1, 2, 3, and the maximum value. Of course, the minimum value is the lowest value in the chart, which we can clearly see is 59. The maximum value, from looking at the data up above, of course, is 74. We have previously worked out quartile 2, the median, by locating the number in the middle, and that is to take the average of 64 and 66. We have 65 is quartile 2, the median. Now, something new and different here is how we find quartile 1. What you need to do is take a look at the first half of the data. And bringing that data and looking at the first half is to locate the median of this data. So again, we're locating a median, which is right in the center. Since there are 15, which is an odd number, there will be a data value appearing right in the middle. And that number is 63. It is the 8th one over. So 63 is quartile 1. Next, we would like to locate quartile 3. what you will need to do is take the the upper half of the data, that is starting with 66 and going out to 74. The oval up above does not include the 66 because it was not possible to fit it in, but the data is here presented at the bottom of the screen. In this data set, you will also need to find simply the middle number. That middle number would be the number 70. Again, the 8th number over in the data set. That 70 is then quartile 3. So basically, to find quartile 2, you found the median of all the data. Quartile 1 is finding the median of the lower part of the data, and quartile 3 is the median in the upper part of the data. Using these values, we would be able then to construct the box whisker plot. First, draw out a scale. The scale needs to include the data values from up above in the 5-point summary. Let's start ours at 55, which would include, of course, the 59 further up the scale, all the way up to 80. First, to construct the box whisker, after having the scale, mark off the minimum value where it would appear by a line segment, and then also the maximum value. Next, connect these with a line. Now, working with the quartiles, quartile 1 appears at 63. Draw a little bit longer line segment for that, as well as for quartile 2 at 65, and quartile 3 at 74. At 70. And then finish off the box. As you can see, we now have the box whisker. Something important to note about this box whisker is that from quartile 1 to quartile 3, this is called the interquartile range. From previous looking at what the quartiles mean, 50% of the data would be located in the quartile range. Let's look at another example using the box whisker that we had before, and now again you're being asked to find the range of values contains 50% of the data. This one's different in the values, the answers down below. Again, 10 to 20 does not work because that will represent 75% of the data. However, 13 to 20, you will note it starts at quartile 1 and ends at quartile 3. This represents the interquartile range, which we've just discussed represents 50% of the data. And so therefore, 13 to 20, letter B, is the answer for the interquartile range of 50%. Next, what you will need to know is to calculate and select the appropriate measure of central tendency. We've talked about that already, but it is now looking at the stem and leaf plot. The stem and leaf plot is made up of two parts, that of the stem and of the leaf. We're going to, again, use the data from the sample of junior high students' heights and construct the stem leaf plot. First, you will need to draw a vertical line and then a horizontal for the stem and the leaf. The stems will be the number in the tens place. As you can see, we have two numbers, 59 and 59, for the stem of 5. So 5 goes in as a stem. And then for those of 60 all the way up to 69 would have a stem of 6. Again, in the tens place is a 6. Followed by, again, tens in the, you have 7 in the tens place, so 70 to 74 needs the stem of 7. To finish off the stem leaf plot is to take the ones place for each of these stems and to write down the ones place values. So we have 59 and 59. That includes 2 with a 9 in the 1. So we write those two numbers down under the leaves. You'll notice 60 all the way up to 69 has several data values, and we include, again, only the ones place under the leaves. And then from 70 to 74, we write down the ones place for those particular data values. From this chart, we have now a representation of all data values and a graphical picture of where we can see most of the data. This can be used to answer several questions. For example, in example 3, we have another stem leaf plot. It's a different one. You will notice that the first value in this, in the tens place, is a 12. So that would be 120, in the ones place 9, representing 129. The next one would be 133, and so forth. You're being asked, what is the median of the data recorded in the stem leaf plot? We've already seen that the median is a number that appears in the middle. And from this data, we can count over, there are 30 data values. So again, there's not going to be a specific data value right in the middle, but there will be 2 that we need to locate. So counting over 15 data values brings us to 149. The 16th place, we will see that there is the 150. So we need to take the average of 149 and 150, and that will give us the median, which is 149.5. So answer is letter B. Next, you will also need to be able to understand the difference between probability and odds in a particular situation. By definition, probability is favorable outcomes over total possible outcomes. If we are rolling a number cube, there are a total of 6 different possibilities. If we would like to roll the number 2, there's only one of those favorable outcomes on the die. So when we roll the number cube, to get a 2, the probability would be 1 out of 6. However, when we look at odds, by definition, it's favorable outcomes over unfavorable outcomes. Back to our the previous example, we roll the die. Favorable outcome being a 2, there are only one of those. Those that are unfavorable be all the other numbers on the number cube, which would be 5. And so therefore the odds of rolling a 2 would be 1 to 5. Using these definitions, let's look at example 4. If the odds are 3 to 5 that a vehicle randomly selecting from a parking lot is a truck, what is the probability that it is not a truck? Well, from the odds ratio given to us, first of all, we see that the favorable for trucks is 3 and non-trucks would be 5. Therefore, the probability of not being a truck would be 5 over the total number of vehicles. We need to add the 3 and the 5 together, giving us 8. So therefore, the probability of not selecting a truck would be 5 to 8. Example number 5. The chance of rain is 2 to 5. What are the odds against rain occurring? Again, chance is the same thing as probability. So from the ratio given to us, favorable is 2 over total possible 5. Odds of against raining would be 3 then out of 2. Since 3 is the number of days that it would not rain out of those that it would rain of 2, the answer is 3 to 2. Example number 6. The 9 chips shown above are placed in a sack and then mixed up. Madeline draws 1 chip from the sack. What is the probability that Madeline draws a chip with an even number? First, you need to count up how many chips have an even number on them. Well, that would be the 2, 4, 6, and 8, making 4 of the 9 chips. So 4 out of 9 would be the probability of Madeline that she draws a chip that has an even number on it. 4 to 9. Example number 7 will be a problem where you will need permutations or combination formulas. These two formulas are on the formula sheet that you will have with the PSSA. They are given here. Permutations is n factorial over n minus r factorial. It's important to note that the n represents how many you're selecting from, and r is actually how many you select. Permutation, the important point in understanding when you use this formula is that the order is important when you select the items n r number out of n. And so the important thing to remember to use this formula is order is important in the arrangement of the selections. Whereas in the combination formula, you'll notice it has another divisor, r factorial, reducing the total number value, and therefore this comes from a situation where order is not important in the situation. So the difference between these two formulas is, of course, the r factorial in a combination, reducing that value, and that's when order is not important. And remember again, is the total amount you're selecting from. R is actually how many you are selecting. So, in this example 7, a contractor is building 5 different model homes on 5 adjacent lots on one side of the street. If one house is to be built on each lot, how many different arrangements of the 5 houses are possible? Since each house is different, the arrangement, the order is important in giving you a different type of arrangement of how the houses are built on the lot. So order is important in this problem. Therefore, this is a permutation problem. Now, how many lots are we going to use? There are 5. We're going to use all 5, and we're going to use 5 different model homes. So therefore, it is a permutation of 5, 5. Using the formula 5 factorial over 5, which is the n minus r, 5 minus 5 factorial, you have 5 factorial over 0 factorial. Something important to remember, 0 factorial by definition is 1. 5 factorial, understanding what factorials are, is the factors 5 all the way down to 1. And in the formula then, if you multiply those numbers, you get 120. It is possible from the calculator workshop that you were given how to find permutations, combinations with the calculator. You should use that formula, if it's possible to use that on the test, your calculator. Use the permutation and combination keys on your calculator to come up with the permutation here, 5, 5, and you should get 120. What you'll need to know next is to develop and to evaluate inferences and predictions or draw conclusions based on data and data analysis. Example 8. From a shipment of 500 batteries, a sample of 25 was selected at random and tested. If 2 batteries in the sample were found to be dead, how many dead batteries would be expected in the entire shipment? If we look at the ratio of dead batteries to the total number in the sample, we get a ratio of 2 to 25. We would like to set this equal to a proportion that equals the ratio x over 5, a problem that you're familiar with in cross multiplying. So when we cross multiply, you end up with 25x equals 1,000, dividing by 25 yields x equaling 40. There will be then an expected value of 40 of the batteries out of the 500 that will be expected to be dead. Next, we'll make predictions using equations or graphs of best fit lines of a scatter plot. The annual maintenance cost of an appliance is given by the regression equation, and you have it given there, where y represents the total maintenance cost and x represents the age of the appliance in years. Rounded to the nearest dollar, what is the expected maintenance cost of a 14-year-old appliance? Remember, x represents the age of the appliance. So we're going to place 14 in where x is, making a substitution, and simply multiplying and adding the 19.2 on gives us 194. Therefore, we would expect the cost to be $194 for this appliance of 14 years old.
I'm working on a project right now, so I promise I will call tomorrow and schedule.
Example 10. Which of the given equations most closely represents the line of best fit for the scatter plot given below? Now, by line of best fit, we would try to fit the best line between all the given points. Now, this will not be a line that has all of the points on because they're not linear. However, if we were to draw in a line to try to best fit all those points, it would look something like this. You will note that this line is going through the y-axis at 8. That means it has a y-intercept of 8, and all of our answers, you will note, have 8 as the y-intercept for those lines. So to differentiate the difference of which line is the best, we need to work with the slope. The slope of this line, if you look at it carefully, we went from 8 up to 10. That's a difference of 2. And over a length on the x-axis from 0 to 2. That's a distance of 2. So it's close to a 2 to 2 ratio for slope, which would be 1. Therefore, the line of best fit would be that of letter B, y equals x plus 8. The last, a definition on outliers. An outlier is a data value that is much higher or much lower than the other data values. If we take our original data set for heights of students in the junior class from the sample, you will know I have included one more at the end. That is the 96. That is extremely high for the height of a student, and that would be what's called an outlier. It is, again, a value much higher or much lower than the other data values. In your next Bullseye presentation, geometry will be the topic. Some of the areas that we'll be looking at is to formulate and answer questions that can be addressed by using concepts and formulas from geometry. Apply facts about right triangles and Pythagorean theorem to find missing sides and perimeters. Understand and apply basic ideas about similarity of plane figures. Apply geometric formulas for surface area and volume of 2- and 3-dimensional figures. And recognize the correct units for length, area, and volume. Thank you.